that is electrostatic potential and capacitance. Before diving into the concept, I will explain you that what is the depth of this concept. See, first of all, before proceeding further, what is the meaning of capacitor and what is the meaning of capacitor? According to you, what is a capacitor? Yes, see, whenever you're storing the charge, that device which stores the charge is known as capacitor. And how much the capacitor can store will be given by a word that will be known as capacitance. How capacitor looks like? Capacitor looks like a cylinder. If you want to see the capacitor, open up your fan. You will easily see the capacitor. It is outside the fan at the in the fan. This is our fan. Here we have a cup-like structure. If you remove this cup-like structure, here you will get the capacitor. Okay, then we'll see what is capacitor. So for capacitor, okay, what is capacitor? So as a key point, I can say capacitor is a device. It do what? It do storage of energy. Okay, and it store energy. Energy will be stored in the form of what? It will be stored in the form of charge. And from where we are getting charge? Charge we are getting from electric field. So electric field from energy. Okay, now what is this thing? Means what is energy storage? Why it is necessary for the storage of energy? That is considered we have a surface. On that surface we have a bucket. We have a bucket. We have a surface. On that surface we have a bucket. Okay, and if you're trying to pour the water, it can be poured only to this point. After that, what will happen? After that, there will be the leakage. Same goes for the charges. You can store, see, in capacitor also. Capacitor is a device which store the charges. In capacitor also, you can store charge up to some level. After that, what will happen? Charge will get leak. No? Charge will get leak. So how we can come to know that this can be filled up to this point only? So for that, we on the charger you will easily get a notation in terms of microfarad, like 6 microfarad, like 8 microfarad, like 10 microfarad, like 20 microfarad, and so on. So from this we got we have the unit of capacitor. It will be what? It will be farad. Now, I'll give you for a few more formula for this, then we'll see what is there in the theory part. We have formula. Just remember the formula. Formula is quick climbing valley. Yes, Q is equal to C into V. What is Q? What is Q? Yes, Q is charge. And what is C? Capacitance. What is V? Voltage. Charge, capacitance, and voltage. Charge, capacitance, and voltage. If we want to find capacitance, so what will happen? To find capacitance, we'll write Q upon V. Q upon V. What is Q? Q it is in terms of the coulomb. What is V? V is in terms of voltage. Coulomb per voltage. Coulomb per voltage is known as what? It is known as farad. So we can say the unit of capacitance is what? It is farad. Farad. Or you can say microfarad, or you can say nanofarad, or you can say picofarad, or you can say C upon V. Okay, once more, I'll give you the formula. I will give you the formula for C, and I'll give you the unit. Then we'll see what is there in the text, what is there in our notes. So what we have Q equals CV. Quick climbing value. What is Q? Charge. What is C? Capacitance. What is V? Say voltage. So what is C? C will be equal to Q over V. What is Q? Charge. What is V? Voltage. So this will be equal to what? This will be equal to C upon V. What is C? C is our coulomb. What is V? V is our voltage. So now the unit will be what? Your unit will be microfarad, nanofarad, picofarad, or coulomb per volt. Okay, once more. What are the units? Units can be first one, farad, microfarad, then we have nanofarad, then we have picofarad, then we have C over V. Okay, these are the units. Now let's see what is there in the top, what is there in our what is there in our notes. First thing, two conductors are separated by insulator makes up a capacitor. Two conductors which are separated by an insulator makes up a capacitor. Okay. The conductor have potential V1 and V2 as well as charge Q1 and Q2. To provide just two examples, the two conductors typically have of charge plus Q and minus Q and a potential difference of V is equal to V1 minus V2 between them. We will merely consider this capacitor charge setup. Even a single conductor can be utilized as a capacitor. By attaching the conductor to a battery, two terminal, the conductor can be charged in this way. Q is referred to as a capacitor charge, although it is basically just a charge on one of the conductor. The capacitor has no charge. In the space between the conductor, the electric field is proportional to charge. In other words, if charge on the capacitor, let's say double, the electric field will also be what? It will be doubled. The symbol for capacitor and variable capacitor is shown in this figure. I will explain you what is the symbol. Symbol can be represented by this. It can be represented by this. This is fixed capacitor and this is variable capacitor. This is fixed capacitor, this is variable capacitor. This represents our voltage regulator, the voltage regulator. Okay, then we have already discussed the formula. Still, we'll see what's there in the theory. The capacitance of system is defined as the ratio of charge corresponding to electrical potential. So capacitance is given by charge over potential. The capacitance of capacitor is denoted by constant C. The capacitance C is only dependent on induced surface charge density resulting from a uniformly polarized dielectric. But there is no induced volume charge density due to geometrical configuration of the system of two conductors. We also depend upon the types of insulator used to separate the two conductors, as we shall see in more details. 1 coulomb volt or 1 farad is equal to what? It is equal to 1 coulomb volt in SI system of measurement. According to the capacitance equation, V is small for given Q when C is large. V is small for given Q when C is large. See, if you are considering that, see, from where we got this formula, from, as we are increasing the charge, V will get increased. 100%? Yes. If we are removing proportionality sign, we'll get constant, and that constant is C. So your C will be equal to what? The C will be equal to Q upon V. C is equal to U upon V. What is Q? Charge. What is V? Yes, potential difference. If you are thinking that if we reduce V, capacitance is increasing, you are thinking wrong. I repeat, yes, I agree. The formula is this, but once again, I'll explain. Check what I told. I told that Q is directly proportional to V. After removing proportionality sign, everyone knows who comes. Who comes? The constant. The constant is what? C. So your C will be equal to what? This will be equal to Q upon V. If you are thinking that increasing V will decrease C, you are wrong. Yes, you are wrong. See, if you are increasing V, if you are increasing V, if you are increasing V, charge directly proportional. Charge will be what? This will be also be directly proportional. So our ratio will get balanced. C is constant. C will have no impact. C will only depend upon the material. It depends upon the surface charge density, not on the voltage or charge. Okay, understood? Yes. Next is practically practically Strong electric field must surrounded the conductors because of high potential difference. But the charge on capacitor plate can be partially neutralized by strong electric field, which can ionize the surrounding air and the speed and the charges, so produce to oppositely charged plate. To put it another way, the medium in between loses some of its insulating capacity, causing the capacitor charge to leak away. The dielectric strength of the material is the highest electric field that it can withstand without its losing its insulating ability for air. This value is around 3 into 10 raised to 6 volt per meter. The field corresponding to potential difference of 3 into 10 raised to 4 volt per meter between the conductors at around 1 centimeter between them. Therefore, a capacitor capacitance must be high enough to prevent breakdown limitation from being exceeded so that it can hold significant quantity of charge without leaking. What are the application of capacitor? It have many applications. We'll see some basic application. First application is the capacitor. Primary function is the storage of electrical energy. Storage of electrical energy. Additionally, it serves a temporary battery to keep power on even when power is turned off. Okay, it is a storage of if it can store electrical energy, then when we don't have any kind of power and we can use its power, temporary battery, it's a kind of a temporary battery. Third, the capacitor is required in both residential and commercial appliances such as batteries, fan, camera, cooler, electronic charge, LED lights, audio equipment, etc. Fourth, the capacitor banks are frequently used in power system to control voltage and enhance the quality of power supply. The capacitor is also frequently utilized in computers during emergency system shutdown. Okay,